Okay, so the question was asked about the two-sided hypothesis test and how that relates to confidence intervals. So first I wanted to show you an example with our IQ test data. So again, with that whole group, we used a claim of 5.8. So if our alternative were not equal to 5.8, saying that we were just different somehow from that, what result would it give? So again, estimating with the confidence interval, assessing with the test, using our sample mean X bar, which was 6.185. So I just ran the test on the calculator under stat test and then the two sample t test. So the test statistic still has 53 degrees of freedom, just like the confidence interval did. And the same thing as our one-sided hypothesis test that we did originally when we said greater than. The test statistic is 2.102, which is exactly the same. But because we're now looking at an alternative that's greater, because we're now doing one that is not equal to as opposed to greater than, it changes our p-value to twice what it was. So instead of about 2%, it's at about 4%. So I put all this information in a table to try to make a little bit more sense of it. If we used a confidence level of 90%, this is the interval, which again, I just got from my calculator. This just misses the 5.8. It's a little bit above the 5.8. So if the 90%, the complement of that, thinking using an alpha level of 10% or 0.10, we have a p-value of 0.04, less than the alpha level, we would reject the null hypothesis. So the confidence interval missed it, which means my p-value is small enough that tail area that's left over, it's going to end up also missing. Okay, I did the same calculations for 95%. So my interval now, because I increased my confidence level, is a little bit bigger than it was at 90%. Still misses the 5.8 though. And so it's everything, all the values in my confidence interval are greater than 5.8. 95 would correspond to 5, so 0.05. And because P is still less than that alpha level, 0.04 is less than 0.05, we are still rejecting the null hypothesis. So when we get to 99, our confidence interval is even wider. We have to go farther away. So again, in the confidence interval, we're keeping the same X bar, same S, same sample size, but that T star is getting increasingly bigger. And so it's making the interval wider and wider. Now I have to go far enough to either side of my 6.185, which is my center, to capture 99%, that it does capture the 5.8. And so 99% would correspond to 0.01. And because my p-value is now not less than my alpha level, I fail to reject. Okay, so to try to visualize this, to make sense of this, and we worked through an applet that dealt with this. If we think of our sampling distribution, it could be a bit more symmetric, look less than a little flipped up hairdo, but that's okay. If the truth is supposed to be at 5.8, our sample mean of 6.85 was just a little bit more than 2 standard deviations away. That's what our test statistic is telling us. So if I take my 6.185, and if I think to go left about 2 standard deviations. So if I do a -2 times S over the square root of N, or if I go to the right that far, +2 S over the square root of N. Now, again, 2 is just an approximation. That is not the right critical value, but just thinking roughly in terms of our 68, 95, 99.7, since that's a number that we're used to, I have to go however far, whatever T star is, from my X bar. And that creates the boundaries. When I multiply that by S over the square root of N, that's my margin of error. That gives my boundaries for my confidence interval. So if I'm that far past it, then when I try to go back, I can't catch my middle anymore. Okay, so then finally the 2 sapling questions. This should be number 15, and then number 21 we will take a look at. So the p-value for a 2-sided test, if this is my null, then all this question is saying is that my alternative is not equal to 10. That's what 2-sided means, and it's 0.06. So this is only for p to be less than alpha less than alpha. My alpha level has to be 0.10. Anything else, it's not going to work. 6% is not less than 5%, and it's not less than 10%. So if I look at my answer choices, first, these ones are garbage. That doesn't even make sense. It's not going to contain the p-value. So if p is only less than alpha when alpha is 10, then that means for my confidence interval to match that, it would have to miss it at that point. So 90% is going to be too small to capture the 10. At 90%, I would reject the null hypothesis, which means that the confidence interval would not include the value of 10, which is why at 95% now my confidence interval is just a little bit wider. And so the wider the confidence interval now is able to capture the 10, which is why if my p-value is 0.06 and I were using an alpha level of 0.05, I would fail to reject my alpha level, fail to reject my hypothesis at an alpha level of 0.05. Okay, and then here to finish up is number 21. So similar setup, they just told us the null this time instead of making us work out the null and alternatives ourselves. The p-value is 0.022, which is less than 10% and less than 5%. So I would reject at those levels. It is not less than 1%, which is why the first bubble is the answer choice. So 1% corresponds to the 99%. So that would be wide enough that it would capture the null hypothesis. The 95 would not, and so we wouldn't believe that it were equal to 1, and neither would, and 90% if that had been an option.